have more than one independent variable, right? Even though we said that more than one independent variable, but heat equation and wave equation, these two equations only have two independent variables, which are x and t. To limit kita scope lah. Otherwise kita tak nak lah kalau you nak more than two independent variables, then the solution punya tu lagi panjang lah untuk nak selesaikan kan. Alright, so we are going to focus on the heat equation and wave equation that have two independent variables, and the independent variables are x and t. X we call it as partial variable, t is time variable. Alright, okay, so we can separate the variable x. We are going to solve it separately, variable x, and we're going to solve it separately, variable t. Alright, okay. So method of separation, this method is one of the method used to solve PDE analytically. Okay, we have another few methods, okay, but however, I think most of the engineers, they're going to learn only method of separation variables to solve PDE analytically. Right, and the other last 2 weeks of this chapter, you are going to learn how to solve PDE numerically. Right, so the basic idea is to assume that the original function of two variables can be written as a production of two functions. So this is the basic idea. You're going to start with this statement that uxt is equals to the solution of x times the solution of t. All right, so we are going to write it as capital X as a function of x and capital T as a function of t. Okay, what does it mean? The solution of x times the solution of t, because we can separate the variable. Okay, we are going to solve variable x and variable t separately. Right, then once we have this assumption, we are going to apply into the PDE. All right, then the PDE will be reduced to two ordinary differential equations. Okay, bila dah reduce jadi two ordinary differential equations, then how are we going to treat the ODE? We're going to apply the method that you have learned in ODE chapters. Okay, you understand me? Okay, you can combine the solutions of ODE. Right, then we go back to this statement, this assumption. We have the solution of x, we have the solution of t, then we can just simply multiply the solution of x and t, then it will give us the solution to the corresponding PDE. Step 1. Okay, are you ready? Step 1. Okay, we are going to assume, okay, we'll start with assumption that the solution of uxy, which is the PDE that we are going to solve, equals to x solution of x times solution of y. All right. Okay. Then reduce the linear PDE to two ordinary differential equations. Okay. Once we have made this assumption, right, that uxy equals to x times y. Ini jadi dua separate kan? X ni as a function of x sahaja, y ni as a function of y only. Alright, then del u del x, we are going to differentiate u with respect to x, y remains constant. That's why you bila you differentiate this one, it becomes x prime y. Why just y lah? Because you differentiate the u with respect to x. Okay, boleh faham?
Boleh.
Okay, now look at the second one, del u del y, then x remains constant, y you differentiate and become y prime. How do you get this from this equation, from this assumption? Okay, if you have del squared u del x squared means you differentiate u with respect to x 2 times, right? So double second derivative of x times y. Okay, if we have del squared u del x del y, then it becomes x prime y prime. Kenapa? First derivative is with respect to x, then you get x prime. Second with respect to y, then you get y prime. You can only do this if you can separate the solution. Alright? That's why we call it as separation method of separation of variables. Right? Dengan ada assumption that the solution of PDE uxy equals to x times y. Right. So next, divide the ODE with uxy equals to xy. Hence, we a separation of variable on both sides of equation. Alright? Okay, so I'm going to give you the step. Nanti kita akan solve one complete solution. Boleh? Okay, this is an example. We have del u del x equals to del u del y. Okay, we're going to let u equals to x times y. Right? In the left hand side, you differentiate u with respect to x, then it becomes x prime y. Okay? Equals, in the right hand side is del u del y. In the right hand side is del u del y, then it becomes x y prime. Okay, kalau tak faham, you just throw your question. Switch on your mic and throw your question. Okay, once you have this, how do you get this? From the PDE. Okay, then we're going to divide the derivative here, okay, by xy, both sides. So we divide by xy, both sides. Alright. What can you see in the left hand side? You can cancel y. What can you see in the right hand side? You can cancel x. Right? Therefore, the equation becomes x prime on x equals to y prime on y. Can you separate the variable? Left hand side only variable x, right hand side only variable y. Okay? Right. Okay. So we can say that the PDE is separable. Bila PDE is separable, then we can use this method to solve the PDE analytically. Okay, let's move to the step 2. Step 2, we're going to solve the separated equations. Okay, now we have this 2 ODE. X prime over x equals to y prime over y. Macam mana kita nak make sure that we conserve the equality? Equality x prime on x sama dengan y prime on y. We're going to let them equals to a constant k. Then x prime on x equals to k. Y prime on y equals to k. Right? You don't change the equation, right? Because again, bila you combine this, is x prime on x equals to y prime on y. Okay, so what happened? Rearrange, it becomes x prime minus kx equals to 0 and variable y prime minus ky equals to 0, right? So this is why we say that it can be reduced into 2 ordinary differential equations. When you solve this equation, you only solve x as a function of independent variable x. And the second equation, you are going to solve the independent variable y. Alright, then k ni, the value of k here has three possible cases. K can be positive, k can equals to 0, and k also can be negative. So we don't know what is k, right? K boleh jadi positif, boleh jadi kosong, boleh jadi less than 0. Alright, so we have to consider all 3 possible cases in order to find the analytical solution of the PDE. Alright, so means that we're going to solve one by one. When k less than 0, what is the solution? When k equals to 0, what is the solution? When k greater than 0, what is the solution? Alright, okay. Okay, then this is how you do it. If k is positive, k equals to lambda squared. Kenapa kita let it equals to lambda squared? Because lambda squared is always positive. Doesn't matter lambda is negative or positive. When you have this squared, then it give us k always positive. You masukkanlah dalam you punya ODE. So x prime minus lambda squared x equal to 0 for the independent variable x. Then y prime minus y lambda squared y equal to 0 for variable y. Okay, this one is just you're gonna have this x prime equals to lambda squared x. So x prime on x equals to lambda squared. Right, then we kita boleh splitkan dia. Dx sama dengan lambda squared dx. Nampak beza dia? Satu capital X, satu capital satu small x. Then this is 1 x equals to lambda squared x. Okay, then x equals to C1 exponent lambda squared x. Alright, so I hope that you can recall the first chapter of ODE. Okay, so how to solve first order differential equation. So this is actually the steps on how you can get this C1 exponent lambda squared x. Okay, alright, then kita dapatlah solution of x. So we got the solution of y. Then the solution of ux when k is positive is x times y. Kita darabkanlah because this is our assumption, right, in the beginning. Solution of x times solution of y. Then we multiply this, we can simplify. Alright, then we get a1 exponent lambda squared x plus lambda squared y is the solution of the PDE when k is positive. Alright, move to when k is 0, equal to 0, then x prime equal to 0, y prime equal to 0. Alright, this is simply a constant. Okay, when you solve the derivative, okay, so first, okay, we have just dx. Okay, nak dapatkan x, you integrate lah. Integrate sebelah kan. Walaupun nampak the answer is 0, but remember when you differentiate C3 a constant, then you get 0. That's why x equals to just a constant. Alright. Okay, this is solution of x, this is solution of y, then the solution is uxy equals to x times y is equals to C3 times C4, C3 times C4, then equals to A2. Right, so uxy equals to A2 is the solution of the PDE when k equals to 0. Right, then move to when k is negative, k equals to negative. Alright, when we solve this, this is solution when of x, this is solution of y. Alright, this, okay, you multiply this, the solution of x, the solution of y. Okay, this is you simplify. Alright, then this is the solution of the PDE when k is negative. Alright, then we're going to apply the boundary conditions. Alright, remember in my first video, I talk about what is boundary condition, initial condition, boundary value problem. Boundary conditions is something that relate to space variable, spatial variable. How and the initial condition relates to time variable. Okay, kenapa boundary to space? Of course lah, because apa namanya, on space lah we have boundary. Alright, we can't say in time variable we have boundary. Alright, okay, so time variable we call it as initial condition. The information about the conditions on the boundary we call it as boundary conditions in spatial variable. Alright, nanti I will show you how to do this. Okay, step 4. Then when we have solved the two different ODE, alright, and we combine it together, okay, the solution of uxy equals to x times y. At some point there is an unknown constant. Okay, for example, in this slide we have this unknown dn. Right. How to find the unknown dn? We're going to use Fourier series. Alright, okay, that is step 4. Then principle of superposition, it says that the complete solution of linear PDE is the sum of all solutions, all possible solutions. Alright, remember tadi kita ada solution when k greater than 0, k equal to 0 and k less than 0, represent k positive, k 0 and k negative. Therefore, uxy, the solution of PDE is equals to u when k positive plus the solution of u when k equal to 0 plus the solution of u when k less than 0. Right. So I think this is just the introduction of method of separation variables.